Okay, so in this section, we are going to perform some NumPy operation in Jupyter Notebook. In order to work on NumPy, we need to import NumPy package. So first let's go and import this NumPy package. So we can do that with the help of import NumPy. Now, just like in Python, we had list which we were creating and working on that. Similarly, here we don't create lists like this. So if you remember in Python, if we used to do like this, it used to create a list for me. But in this particular case, it is going to be a little different way. So we have to say numpy dot array, and now I will pass it as a list only, like 1 2 3. But only difference now is that if I just say 1 2 3 in the bracket, it was basically just a normal list. But when I passed it in a numpy array, it became now as a numpy array format. Okay, we will see the advantage of it as we have learned in the last lecture, that it do help us improve the performance and all. So we will learn all of that structure. But if you notice that in every command, if I have to type numpy before talking about any other command, then numpy, though it is not very huge word, but still it's a big word. Can I reduce it a little bit? Yes, you can. You can create a shortcut by saying import numpy as np, and you can notice now this np is going to be my alias or a shortcut for numpy. Now I can easily say np.array, and now if I pass 1 2 3, it is exactly going to do the same thing. Okay, it created a array which is a numpy array now. Now I can save it into a variable if I wish to, like I can say a is equal to this, and if I print out the value of a, I can see this part. Similarly, just like you have a nested list, similarly you can also create a nested numpy array as well. Like you can say np.array, and you can see that I can pass 1 2 3, and basically after this I have to pass 4 5 6. Will it work? No, because these two are, you need to bundle it together, right? So you need to do this bundling part so that it will start treating it like an nd array now. And now if you see the value of b, you can see that it's showing up like a matrix. If you want to confirm, you can always say b dot shape. What this is going to tell you? This is going to tell you what is the dimension of this particular array. Now there are two things into your dimension. Let's say you have an array like this, a b c d e f. Now this part represent row, okay, the horizontal part, and this part represent column. Now how many rows are here? 2, so I would say 2. How many columns are here? 3, so I would say 3. So this becomes my dimension. Now look at this, match with this, this is exactly same. How many rows are here? 2. How many columns are here? 3. That's the reason you got 2 comma 3 when I did this particular shape. So this is how you can check a particular dimension of a numpy array. Now similarly, remember I have even a vector a like this, numpy array a. If I do a shape of this, it was, if you remember, it was a 1D array, so it is 3D 3 comma this, because there were only 3 elements to it, right? You can always do that by looking at the shape element. Similarly, if you want to check that in my b, what kind of data elements are present, and if you remember I talked about in numpy you can keep homogeneous element. Similarly, you can check that how many what type of elements are present in this array. So you can type a command d type. Okay, so basically b dot d type. This command is going to return that what kind of elements are present in it. So you can see that it's telling that it's an integer 64-bit basically array type elements what we have. Now let's check that what is the total number of rows present in it. I can do it with help of shape, but there's also one more thing, n dimension. So it will return you only 2, like how many rows are present in that particular numpy array. At any moment, if you want to check that what is the type of a or what is the type of b, so you can always say type of a, and notice that it's going to tell me that it's not a normal list, but it is an nd array which is of numpy type. Okay, n dimensional array which is of a numpy type. You can do the same thing even when you want to check for B array also, you can see that this is also going to return me, that is a NumPy type. Now, just like in list, if you remember, we had ways that if I have to type, let's say, the value from between 1 to 100, I need not say go and say that 1 comma 1 comma 2 comma 3 till 100, right? Similarly, in NumPy array, if I want to avoid that, I don't want to type all these things, but instead maybe I want the value to be starting from 0 and maybe go till 99. Can I do that? Yes, without writing it in the form of list. There is a command for it called as arrange. So in NP, we have a command called as arrange, and if you pass, let's say, the value 100 to it, this is gonna return you the value from 0 to 99. You can see that if I would have passed the same thing as 10, then this would have returned from 0 to 9. So what happens here is the last value it ignores, because the index will start from 0. So the last value it is going to ignore. Other than that, it is going to print out everything for you. Now, as I was continuously telling you that NumPy is fast, and I've explained you a lot of reasons behind it in your first lecture, now I want to show you up practically that see NumPy array is really faster. What I'm going to do this time is I'm going to create a value basically till 10,000. So I'm using the range function, which is going to return me the value from 0 to 9999. Okay, so let's create that. Now what I'm going to do, I'm going to use the timeit function of Python. This is going to tell me up that how much time this execution is going to take. Now execution for what? Execution of, I want to basically do an exponent with the power 3, means whatever the value is going to come up, I'm just going to raise to the power 3. So 1 cube is 1, 2 cube is 8, 3 to the power 3 is 27, and so on. So for what value? For I in C. So if you remember, in C I had the value from 0 to 9999. So I'm gonna just run it over this loop and gonna see that if I'm using a normal list C, because C is my normal list, normal Python list, and we'll see that how much time this is gonna take. So let's just execute. It will not take much time, so don't worry. So you can see that it took around 4.35 millisecond plus minus 11.3 microseconds, right? Now, if I would have done the same thing with NumPy, let's see that how much time it would take now. On the same machine, everything same, let's just do a comparison. So let's say now I will say that C underscore NumPy, this is just the name of this NumPy array, np.arrange, and just like range, I do have this function. So here I can pass 10,000 values. So this is my NumPy array now. Now let's again put a timeit just to check how much time this is going to take. And here I need not write all that loop. Okay, this is very convenient. As I said, you can just say this into 3, it is automatically going to loop and return you exactly the same result what your list is going to return. Now if you do this, let's compare the time. Can you see here? The time have definitely improved, because this is 4.35 into 10 to the power minus 3. Here 27.9 into 10 to the power minus 6. Okay, can you see the difference? Even plus minus this value which was there, it was in 10 to the power minus 6, and here it is nanosecond, which is 10 to the power minus 9. So you can see that on a small list itself, when I did some operation, my NumPy is working far faster in comparison to your normal list. Are you still not convinced? Let's look at one more interesting problem. So I'm going to take another example where I'm going to now take up the value of basically the value till 10,000 again. You might be wondering why I'm doing that again, same thing. No, it's a different example. I will take L2 as I'm going to raise it to the power 2, okay, for I in range 10,000. Okay, let's basically execute this. So there are two lists now. One list contains the value from 0 to 999, and there is a second list which contains the square of these values. Okay, now I'm going to perform some operation. What operation? I will multiply both this list. Okay, let's see that how much time it's going to take if I'm going to use as a normal Python list. So I'm going to say timeit I want to return the output in form of list. I'm going to apply this function lambda x comma y. Now I can say colon x multiplied by y comma L1 comma L2. If I execute this, let's see what's gonna be the output, how much time this is gonna take if I'm just running it with this. So it's gonna take 2.1 millisecond plus minus 15 microsecond. Let's do the same thing on my NumPy array now. What I'm gonna do now, I'm gonna convert my this list into my NumPy array. So I'm gonna say NumPy array L1. This is gonna create my A1 here. I'm gonna create my B1 here, which is my NumPy array format. It is gonna take my list L2. Let's keep this into my NumPy array. Now let's again run the timer. Time it A1 multiplied by B1. And if I multiply both the things, let's see the time. You can notice now again this is 2.1 into 10 to the power minus 3, but here it is 6.84 into 10 to the power minus 6, which means this part is taking much lesser time in comparison to your list, right? So, and can you notice one very interesting thing? In NumPy array, it is so convenient that I need not write even all those for loop. I'm simply able to do my calculations just the way we think in our brain, right? So when I want to do this thing in my list, remember I had to write so much of things, lambda, x, y, so on. Here, do I need to do that? No, I didn't write any loop statement. I just said multiply A1 into B1, and this is exactly gonna do the same thing for me and will take care of everything for me up here. So this is how you can get your outputs. Now let's say I have created a NumPy range and I'm taking the value till 12. Look, it means that I'm going to go from 0 to 11. But let's say I don't want to start with 0, 1. I want to start with 2. Can I do that? Yes, you can do that. So you can say 2 comma 12, and this is going to start with the value 2 instead of starting from the value 0. There's one more thing. Maybe I don't want the value to be continuous. I don't want 2, 3, 4, 5, 6. I want 2, then 4, then 6, then 8, then 10, then 12, like that. Can I do that? Yes, that is also possible. So you can always say np.arrange 2 comma 12 comma 2. This means that give me the space of 2. Okay, so keep on iterating and keep on hovering over the value one by one, and this is gonna return you the value 2, 4, 6, 8, 10, 12, like this. Now similarly, NumPy have lot of interesting functions. Let's go over few of them. Like I would say numpy.zeros. This is gonna return me all the 0 values what we have. But what all values I want? I want basically 3 by 2, means 3 rows and 2 columns. I want to fill it with value 0. You can see that, right? I am getting 3 rows and 2 columns as complete 0 value. Similarly, can I fill 1 to it? Yes, why not? You can say np.ones, and here I can define 3 comma 2, and you can see that 3 rows and 2 columns got filled up with the value 2. Similarly, you can create identity matrix. What is happening in identity matrix? All your diagonal elements are going to be 1 and remaining all values are going to become 0. So how we can do that? We can say npy.I. I can pass the value 3 to it, and you can see here all the value which is present into my diagonal element gonna become 1 and rest of it becomes 0. Also interesting thing you can note here is that we do have a square matrix basically coming up here. So that's the reason the basically row and columns are going to be exactly similar. Similar to this, you can also like right now what I'm doing, I'm just filling my elements one by one, right? But let's say I have a 3 cross 3 matrix, and in the whole 3 cross 3 matrix I want to fill the value 2 to it. So I can always say np.full. I can pass 3 cross 3, that means I want to fill the value in 3 cross 3, and what value I want to fill? 2. So let's see this. This is gonna fill up my value. So I don't have any something called as np.twos, just like we have np.zeros or np.ones. So in that case, I can always look forward for np.full and get this appropriate output. Now, what if I want to also put that basically basically the value which I'm filling up. Let's say for example, if I say here np.fill and I pass 3 by 3 here and I pass, let's say 2.2, means I'm gonna fill, sorry, this should be 2.2. So this is gonna fill 2.2, but let's say I want to insert the value only as integer. Can I do that? Yes. So you can always say d type is equal to np.int. Now this is going to ensure that all your floating values should get converted to your integer value. So you can see that now I get 222, the values basically like this. Similarly, instead of in the diagonal element, if you remember your identity matrix, I was filling in the diagonal elements all the one value, but instead of that I want to fill 1, 2, 3, 4, 5, 6 like that. So you can also do this. You can say np.diag. It basically is a diagonal kind of thing. You will say 1, 2, 3, 4, 5. Now it's going to create a square matrix with only these entries will be kind of the entries which I want in the diagonal, and remaining all it will take it as 0. Okay, so this is how you can always go back and fill up all your outputs. Let's do some more stuff here. Let's perform some more operations in Numpy. Don't you think it's very powerful, right? Till now we have seen so many things which we have understood that how it works. Now let's say I have a vector v which is a NumPy array, and this contains my data 1, 2, 3. Okay, let's say this is my v which contains 1, 2, 3. Now what I want to horizontally stack it. What I mean by horizontally stacking it means I want to kind of tile these elements, stack 3 copies over one each other. Means I had 1, 2, 3, and I want to now add few more 1, 2, 3 to it. 1, 2, 3, 1, 2, 3 in the same order. I want to just keep on stacking it. Can I do that? Yes, you can very easily do that in NumPy. Imagine if you have to do the same all things and list. Yes, you can do that, but it will be very complex there. You may have to write loop and all that, but here it's very simple. You say that np.tile, this function is there, vector v, I want to make it 3 by 1. Okay, means 3 rows I want to add, but I don't want to add any extra column to it. So you can see here that this is going to return me 1, 2, 3 and so on. What about if I change this 1 to 2? Look at this. When I made it 2, that means that even on the column wise, just make it 2 times. Okay, so that's what basically is going to be difference if you use this style function. Now let's say you want to find the random values. It will happen a lot in your machine learning that you have to find out some random values to do your further operation. So there is a function in NumPy called as random. If you do this, this is always going to return you the value between 0 and 1, and every time it's going to randomly return. Like for example, this time you got 0.49. I re-execute. This time you got 0.89. Right? Now this have a very interesting property. Let's say I want a random value between 2 and 50. Can I use this function? Yes, why not? I can use it. So what I have to do to make it 1 to 50, I just need to do a small tweak to it. Maybe multiply this by 50. Okay, but so this is gonna always give me the value from 0 to 50. So but I want to start from 2, right? So I would say plus 2. Right, so maybe this is gonna return me from 2 to 52. That's it. That's what I want. Or even if I want from 2 to 50, I can always tweak again some portion of it and do it. I leave that to you as a homework. Now this is about how you can get this. Can I create a matrix of random values? Yes, you can do that. You can say np.random dot again random, and this time just pass that what is the dimension you want to, like 3 by 3. So it's gonna create a random value of NumPy matrix which you can always use. Now so these are few of the things which you can perform. There are much more things to NumPy. Let's work on it from next lecture.